let me start recording. Forgot to do that. So it should be 0.5. So there's a 0.5 chance that the coin will land on heads. So that's there is a 50% chance the coin, and we'll say on tail. Sweet. All right, so we're flipping a coin. So we already know what the population mean is, or sorry, what the population proportion is. We already know it should be 50%. So say if I get a sample. All right, so say if I get a sample, and from this sample, we start flipping it, and from this sample, we do a confidence interval. So we're gonna do a confidence interval. All right. So if you notice, there's a black line straight down the middle. So that black line represents the population proportion. So this is what we're trying to capture. If you look at this green disc over here, this represents our confidence interval. So if you look at our confidence interval, we have a green confidence interval because if you look at it, our confidence interval is telling us it could be anywhere from 0.43 all the way to 0.62. So if you look at the reason why it's green, it's because it captured 0.50. So does everybody kind of see that the reason why this is green is because it captured 0.50? All right, so we'll go with yes. All right, so let's kind of keep on playing with this. So we'll do another sample. Oh, I have to do it. Let's try to go one where it doesn't capture. Almost. Cool. All right, so let's see this one. If you look at it, it's red. So the reason why this is red, if you look at this one, this interval told us it should be anywhere from 0.294 all the way to 0.486. So if you look at this interval was wrong because it's telling us it should be anywhere from 0.29 to 0.48, but our true population proportion is 0.50. So that way, if you look at it, that's why it's red. So you kind of know, like anytime we do a confidence interval, it's either gonna be right or it's gonna be wrong. But essentially, there's like no in between. Okay, either it is gonna capture the population proportion, or it's not gonna capture the population parameter. All right. Does everybody kind of see that?
Yeah.
Okay, cool. All right, so if you kind of imagine for this one, you don't really want to rely on just one sample. What you really want to do, you want to do this multiple times. So you want to do this multiple times so that way you have more chance of capturing the population proportion versus not capturing it. So what I'm going to do, if you look right here where it says interval, I'm going to change that from 1 to 100. Also, if you look over here, let me get the spotlight. If you look over here, it says confidence level. So the confidence level represents how confident we are in this method. So you're saying if I keep doing and doing and doing this method, how many times would this method be correct and how many times would this method be not correct? So if you look right now, I have it at 95%. So that means if I do this pretty much method 100 times, 95% of the time it should be correct. The other 5% of the time is going to be incorrect. So that's what this 95 confidence level represents. It's telling us like how often is our confidence interval going to be correct, and how often our confidence interval going to be incorrect. So what I'm going to go ahead and do, I'm going to go ahead and do this sample. All right, so if you look at the sample, how many red pretty much interval do we see?
5.
Yeah, so we see 5 red interval. And since I did this 100 times, how many green intervals do you think I have?
100.
Let's try that again. Can remember?
Oh,
95.
5.
There you go. Yeah, 95. Because if 5 of them are red, that means the rest of them should be green. So the rest of them will be the 95. All right, but just kind of know it's not always gonna be 95 green and 5 red. Sometimes, like if you do this again, if you look at it now, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now we got 11 red and we have 89 green. So just know you're not always gonna be exactly 95%. This is just an approximation. Sometimes it might be a little bit higher than 95%. Sometimes it might be lower than 95%, but it should be somewhere around 95%. All right. So now we're gonna kind of mess around, and we're gonna mess around with the confidence level. I wanna see how does my interval react when I change the confidence level. So when I mean react, I mean like, would it get wider or would it get narrower? So what we're gonna do, we're gonna start messing around with this confidence level, and what we're gonna do, we're gonna say, we're gonna lower the confidence level. So what percentage lower than 95% do you wanna do? And if you want, you can put it in the chat.
55.
All right, cool, 55%. So let's do 55%. So let's change that to 55%. So since I changed my confidence level to from 95% to 55%, are we expecting it to be more green or should we expect more red?
More red.
Yeah, so we're gonna expect more red. So the reason why we're gonna expect more red because we lower our confidence level. So now our confidence level is lower. So since our confidence level is lower, our confidence interval is gonna pretty much respond to that or reflect that. So the way it's gonna reflect on it, whenever we have pretty much kind of think about the confidence interval, we're always more confident in the confidence interval when it's wider. Because when it's wider, that means we have more of a range. But if it's narrower, that means essentially you have less of a range. Correct. So we get more red. But what I want you to see, I want you to see what's going to happen to the shape of the confidence interval right now. So what happened to the shape of the confidence interval? Did it get wider or did it get narrower?
Never.
It got narrower. And the reason why it got narrower, because now since we're less confident, essentially what we have less options. So it got narrower because now it's giving me a smaller range. All right, so let's see what happened if I increase the confidence level. So say if I'm super paranoid and I always want to make sure that this is correct. So I say this is 100. So I always want to be correct. So I make sure that instead of doing confidence level like 95% or 55%, I want to do a confidence level of 100%. What do you think will happen to our confidence interval? Do you think it gonna get wider or do you think it get narrower?
Narrower.
What was that?
Hold on.
Wider?
Yeah, so it should get wider because now we're increasing the confidence level. So it should get wider than this. So let's see how wide does it get. So if you look at it, we have no red in this one because we want 100% confident. So since we got 100% confident, this is what we got. But let's look at these confidence interval. All right. So I don't know if you can see that. Let me kind of zoom in on it. So if you look at that confidence interval, and I'll type it into the chat, it's telling me that it should be anywhere from 0.153 all the way to 1. So it's telling me the proportion of tail could be anywhere from 0.15 all the way to 1. But that's kind of a huge range. Like, does that give me anything useful though?
No.
Not really, because it's kind of telling me like, hey, the proportion of tails should be anywhere from 0% to 100%. Like, you kind of already knew that. You kind of already knew it should be anywhere from 0 to 100%. It's like if I tell you, like, say if you lost your car keys and I tell you, hey, your car key is somewhere in California. Like, am I technically correct? Yes, but is that going to help you find your car key? Not really. So that's why, like, when we're doing a confidence interval, we're never going to choose like 100% because 100%, yes, it is always going to be right. But usually this gives me useless information. It doesn't give me any information in order for me to help find what the confidence, well, what the population parameter is. All right. So that's it for this simulation. So I'm going to go back to the notes. So that way we could go over the formula. All right. So for this one, it's gonna be, so if you kind of remember what we went over on, what was that? On Friday, if you remember what we went over on Friday, when we have the standard deviation of the population, we use the Z value. So that's what we're gonna go over today. So today we're gonna go over confidence interval when I have standard deviation of the population. And then tomorrow what we're gonna do confidence interval when we don't have standard deviation of the population. So today we're gonna do confidence interval when we have the population standard deviation. And then tomorrow we're gonna do confidence interval again. But for tomorrow, we're not gonna have standard deviation of the population. We're gonna be using S. All right, so let me show you the formula. All right, so we have something called the point of estimate. So the point of estimate is equal to X bar. So the point of estimate, since in this case, since we're trying to find a confidence interval for mu, in order to find a confidence interval for mu, you're gonna need X bar, because that's gonna estimate what the population mean could be. Because we know X bar is not gonna be 100% correct, but we kind of know it'll lead us to the right direction. Up next, we're gonna have standard error, which standard error is sigma divided by square root of n. So for standard error, all you have to do is get sigma divided by square root of n, and that will give you standard error. Lastly, we're gonna get margin of error. So the margin of error is kind of like your wiggle room. So remember, the confidence interval is a range. So what the margin of error is telling us, it's telling us how much we could be wrong by. So it's telling us we could be wrong by like 5 or by 20 or by 1. So that's what the margin of error is going to tell us. It's going to tell us how much can we be off by. And lastly, this is how we find, our confidence interval. So if you look at it, it's point of estimate plus or minus margin of error. So the plus or minus just means that we're going to do the operation twice. So what we're going to do, we're going to do X bar minus Z star alpha divided by 2 times standard error. And then you have to get X bar plus Z star alpha divided by 2 times standard error. So when you see the plus or minus, it's telling you have to do the operation twice. So if you look right here, I have the negative over here, and you have the positive. So that you correspond back to this.
So you have to do plus and minus together?
Well, you don't have to do it together. You do it individually. So you do X bar minus the margin of error, and then you do X bar plus the margin of error.
Okay.
Yeah. Any question in regard to this formula?
No.
All right. So the last thing is we're going to figure out how to get the Z value. So to figure out the Z value, it corresponds to your confidence level. So to find this Z value, it's going to correspond to your confidence level, and I'll show you where do you find that. So this is a chart you're going to be using. So you might want to write down that chart somewhere. So depending on what your confidence level is, that's going to dictate what your Z star alpha divided by 2 is. So if I tell you you have a 90% confidence level, Z star is equal to 1.645. If I tell you it's 95% confidence level, you use 1.96. And lastly, if I tell you it's 99% confidence level, you use 2.576 for the Z value. So depending on which confidence level you get, this is going to be the Z value that you use. So these are the only three that we're going to be using for this portion. So you don't have to worry about anything else. So if it says 90%, you use 1.645. If it's 95%, we use 1.96. And if it's 99%, you use 2.576 for the Z value. Everybody kind of good with that?
Yeah.
All right, so let's go ahead and do our first problem. Here, give me a minute. Let me close out some of the apps that I have. They're slowing down my iPad. All right, so let's do this first problem. All right, so for the first one, it says a social networking website allows users to add friends and message and update their personal profile. The following represent a random sample of the number of friends for 40 users of the website. Find the point of estimate of the population mean, mu. So source is Facebook. All right, so we have these Facebook people, and we have how many friends do they have on Facebook. So what we want to do, we want to find the point of estimate. So we want to find the point of estimate. So if I go back up here, if you look at it where it says point of estimate, that means we have to find X bar. So that means we just want to find what X bar is. So if I want to find X bar of this, technically what do I have to do with this data set? How would I find the sample mean?
Wouldn't you need to put it in the table of class calc?
Well, yeah, you could do that, but like technically to find the sample mean, how do we usually find the sample mean? Like this is going back all the way to the first test. Like what should I do with the data? I should do something with the data.
You put A equals, and then you can punch all of them in, and then hit the standard deviation button.
But that would be if I wanted to find standard deviation. So for this one, I want to find mean. Well, if you remember for mean, what we had to do, we had to add all the data and then divide it by sample size. If you remember, like way long ago when we found the sample mean, that's how we technically found it. We added all the data sets. So you add all the data and then you divide it by the sample size. So technically, you want to add all of these numbers Once you add all of those numbers, you divide it by the sample size. But yes, we are going to just use class calc in order to do this. So right now, what I'm going to go ahead and do, I'm going to switch over to class calc. There we go. All right, so for class calc, we'll just say A is equal to, we'll just say this, so we'll say 140, comma, 105, 130, 97, 80. So what we have to do, we have to enter all of these numbers, and there's 40 of these numbers. So. Cool. All right, so I enter all 40 of the data set. So now since I enter all 40 of the data set, what I could do, I could go type mean. And then you say, oops, you say mean of A. And that's our mean of A. So we get X bar is equal to 130.8. All right, so that's your point of estimate. Any question for that point of estimate?
No.
So I'm gonna go ahead and just transfer back onto my notes. That way you kind of continue on with the notes. All right. So if you look right here, I put the mean is 130.8, which is also called our point of estimate. So anytime we're talking about the point of estimate, we're just referring to X bar. So let's scroll on down. All right, so for this next part, it says assume the population standard deviation for the number of friends is about 53. Use the Facebook data and construct. So if you look at this sentence, all this sentence is giving us, it's giving us the population standard deviation. Since it's giving us the population standard deviation of 53.0, that's how we know we're using the Z distribution. So since we're given sigma is equal to 53, we know it is the distribution, because for tomorrow, what we're going to be doing, we're not going to have sigma, we're going to have S, and that's why we're going to be using the T distribution tomorrow. But for today, they gave us sigma, so that's why we're using the Z distribution. So let's go ahead and do part A. So for part A, it says a margin of error with a 95% confidence level for the mean number of friends for all users of the website. So right now what I want to go ahead and do, I want to go ahead and find Z star alpha divided by 2. So I want to go find what that is. So in order to find that, all you need to know is the confidence level. So if you look at the confidence level they tell us is 95%. So if you haven't memorized what the z value of 95% confidence level is, what we're gonna do, or what you're gonna do, you're gonna use this table right here. So if you look at the table, it's telling for 90%, for 95%, and 99%. So if we have a 95% confidence level, which value am I gonna use for z? Am I going to use 1.645, 1.96, or 2.576?
1.96.
Perfect. So we're going to use this one because if you look at it, it's telling us 95% confidence level. So let's go back and we'll say 1.96. Everybody good? How we got 1.96? All right. So up next, we're going to get standard error. So standard error is equal to sigma divided by square root of n. So if you look at sigma, sigma was 53 divided by square root of n. So the square root of n is your sample size. So if you remember this data set over here, we found the data set to have a sample of 40. So we're going to be using 40 for our n. So let me do that on my calculator. So we'll say 53 divided by square root of 40. So you get 8.38. All right. Everybody good? How I got my standard error?
Yes.
All right, so last thing we're gonna go ahead and do, we're gonna do margin of error. So margin of error is z star alpha divided by 2 multiplied by standard error. So that's equal to 1.96 multiplied by 8.38. So I'm going to do that on my calculator. So 8.38 multiplied by 1.96, and we get 16.42. So that's it for part A. Okay, part A, all they wanted to do is find the margin of error. So the margin of error is kind of telling us how much we could be off by. So if you remember, this is how many friends do they have in Facebook. So since we get 16.42, it's telling us we could be off by 16 friends. So it could be a plus or minus 16 friends. So as long as we're within 16 friends, our confidence interval should be correct. All right, that's it for A. Lastly, we're gonna do B. So for B, it's a construct a confidence interval for the mean number of friends for all users of the website. So for this one, we had to do the point of estimate. We have to add it and subtract it by the margin of error. So for this one, the point of estimate, if you remember from this problem right here, we found it to be 130.8. So we put point of estimate as 130.8 plus or minus now my margin of error, and my margin of error we found it in part A. So we get 16.42. So that means we're gonna be doing, here, let's use the color. We're gonna be doing 130.8 minus 16.42, and we're gonna be doing 130.8 plus 16.42. So let me go ahead and do that. So we'll do 130.8 minus 16.42, and you get 114.38. Then we do exactly the same thing, but now we add the two, and you get 147.22. And that's your final answer. Any question in regard to how we found that confidence interval at the end? All right. So let's do part C. So for part C, it says now construct a 99% confidence interval for the mean number of friends for all users of the website. Compare your answer with the answer in part B. So if you look at this one is not changing my population standard deviation. It's not changing the sample mean of 130.8. The only thing we're changing is our confidence level. So we're changing our confidence level from 95% to 99%. So since we're changing it to 99%, that means we're going to be using this one over here. So we're going to be using 2.576 for my Z value. So say Z star of alpha divided by 2 is 2.576. All right. Everybody go where the 2.576 come from?
Yeah.
All right.
Yeah.
So, good. All right. So up next, we're going to go ahead and do, we're going to get standard error. So luckily for us, we already did standard error. I'm going to go back to part A. Standard error is 8.38. So 8.38. So in order to get margin of error, so I'm going to put ME for margin of error. You're going to get 2.576 multiplied by 8.38. So let's go ahead and multiply that. So 2.576 multiplied by 8.38. And you get 21.59. So if you go ahead and multiply those two numbers, you should get 21.59 or something pretty close to that. So can I go back to part A? If you look at part A, we had a margin of error of 16.42. But if you look at part C, now we have a margin of error of 21.59. And that's because we increased the confidence interval. So we increased it from 95% and we increased it to 99%. So if we increase the confidence interval, it's kind of showing us the margin of error will go up because it's pretty much we want it to be more confident in it. So once you find the margin of error, last thing you want to do is find the confidence interval. So we're going to do 130.8 plus or minus my margin of error, which is 21.59. So let's do that. So we'll do 130.8 minus 21.59. So if we do 130.8 minus 21.59, you get 109.21. But if now we do 130.8 plus 21.59, let's see what does that give us.
52.39.
Oh, thank you, Aaron. 152.39. And that's it for this one. So also, if you compare these two last confidence interval, you should be able to clearly see that the confidence interval for 99% is wider. Because if you look at the confidence interval for 99%, go from 109 to 152. But if you look at the one for 95%, it go from 114 all the way to 147. So if we increase the confidence level, it should be getting wider also. All right, but that's it for that problem. Any question in regard to how we did that last problem?
No.
All right, so I'm gonna show you how to double check your answer and how to double check your answer using class count. So remember, if the question doesn't ask you to show any work, if it just say find the confidence interval, pretty much what you could do, you could just use class count to do it. So you do kind of want to get comfortable using class count. So that way you could save time on the test. So if you don't have to solve it by hand, just do it on class count for that way you can get the answer faster. All right, so first thing you want to do, you want to go to stats. Then what you want to do, you want to go to tests. And then if you look at it, you have right here, Well, you see how it said T-int, and then you have Z-int. Well, today we're going to be using Z-int. Tomorrow we're going to be using T-int. So for today we put T interval. All right. So if you look at the T interval, the good thing about this, it kind of tell you, well, it gives you two options. So one of the options is you could get to choose stats. The other option, you could choose data. So depending on what's given to you, you want to use one of the two. So stats mean that you already know everything. So you already know the population mean, you already know the sample mean, you already know the N, and you already know the confidence level. Data mean that you have a data set, and you could use that data set, and ClassCalc will find the information for you. So for this one, did they give us all the information, or do we have the data?
They gave us information. I mean, like that we solved it in the data.
Well, yeah, technically we solved it, but they didn't really give us the information since we had to solve it. So for this one, all we have to do is put the standard deviation. So I'm going to choose data, and I'm going to choose standard deviation of the population is 53. I'm going to tell it to look at this list right here. So I'm going to tell it to look at list A, because that's what we named it. And then right here, we're going to put the confidence level. So the confidence level will put 0.95. All right. So if you look right here, it gave us everything. So if you look right here, it gave us the confidence interval. So it says 114.3754 all the way to 147.22. The nice thing about this, it also gave us the sample mean, which is right here, which is 130.8. But also, if you look at it, it gave us a margin of error, where the margin of error is 16.42. So even though if I ask you to do this by hand, you might want to use ClassCalc to double check your answer just to make sure that you did it correctly. So, and then if you look, we could also just change it to 99%. And now give me the confidence interval for the 99% confidence level. And also the good thing, give me the margin error and such. All right. But that's how you want to double check your work with ClassCalc. Any question in regard to ClassCalc?
Where did you get the two lines to put the A in between?
Which two lines?
Next to the A. Yeah, right there. Like for the absolute value.
The bracket. You mean?
Of the bracket? Well, they should come up automatically.
Oh, okay. I thought that was something you put in.
Yeah, because here, I'll show you how it shows up. Okay, it shows up like this. And here, let me double check on my phone. So let me double check the app. Because I think it should show up that way too on the app. So let me change it to graphing. Let's do stats. Let's do tests. Let's do. Yeah, because if you do on your phone, these two lines right here, or the bracket, it will automatically pop up for you. So you don't have to worry about entering it. All you have to do is just pretty much enter the 53, then you say A, and then you say 0.95.
Yeah.
All right, so let's go back to my notes. All right, so let's go ahead and do this one. So for this one, said a college admission director wishes to estimate the mean age of all students currently enrolled. In a random sample of 40 students, the mean age is found to be 22.9 years with a standard deviation of 1.5. So for this one, we know X bar is equal to 22.9. And we know sigma is 1.5. So for this one, it says construct a 90% confidence interval of the population mean age. So they also told us n is equal to 40. So we know x bar is equal to 22.9, sigma is equal to 1.5, n is equal to 40. And we also know we have a 90%. So usually for confidence level, I usually just put CL for confidence level, just to kind of make it a little bit easier on myself. So we're gonna find Z star alpha divided by 2. So for Z star alpha divided by 2, we're gonna use the confidence level. So I'm gonna go way back to that table and I'm gonna look for where does it say 90%. So if you look at 90%, it says Z is equal to 1.645. So we got 1.645. 1.645. So we got that from the table. So now we have everything we need in order to do this on class, well, not on class calc, but to do this by hand. Any questions so far? I got anything?
No.
All right. So first thing I'm gonna go ahead and do margin of error. So to do margin of error, we're gonna do 1.645 multiplied by standard deviation, which is 1.5, all divided by square root of n, which is 40. So let's go ahead and do that. So we'll do 1.645 multiplied by 1.5 divided by square root of 40. Oops. Square root of 40. So if I go ahead and do that, you get 0.39. So if you look at it, I got 0.39. So it's kind of telling us my margin of error is a quarter, well, not even a quarter, a fourth of a person. Or, well, no, sorry, is age. So it's 0.39 of a year. So up next, we're gonna go ahead and we're gonna get the sample mean, which is 22.9, and we're gonna add and subtract it by 0.39. So we're gonna do 22.9 minus 0.39, and we're gonna do 22.9 plus 0.39. And we're gonna see what does that give us. So we'll do 22.9 minus 0.39. You get 22.51. Then if we just add it, you get 23.29. And that's your final solution for part A. Any question in regard to part A?
No, sir.
All right. So what we're gonna go ahead and do, we're gonna go over a class calc and we're gonna double check our answers. So I wanna make sure that these two answers are correct. So we're gonna go over to class calc and double check our answer. So to double check our answer, we're gonna go to stats, we're gonna go to tests, and since we have a population standard deviation, we do the Z interval. So if you look at this one, do they give me all of this information? Do they give me sigma, x bar, n, and the confidence level, or do they give me data?
They give you data.
Right? Well, remember, because data mean is they give me like, so if they say they have 40 students, the data will be if they give me the age of those individual students. So do they give me the age of those individual students?
No.
No, so they don't give me data. In fact, this is stats because since they gave me the population standard deviation, X bar, N, and confidence level, they're essentially giving me all of the stats. So for this one, you want to use stats, and we'll say 1.5 We'll say sample mean is 22.9. We say N is 40, and we'll say confidence level is 90% or 0.90%. All right, so if you look at this one, it gave us 22.509, which the 9 round up to 0 to 0.51, so that's our lower bound. If you look at our upper bound, we get 23.29, which is exactly what we got when we did our. And if you look, we also got the margin of error of 0.39. So this is a nice, easy way to double check your answer just to make sure you're doing it correct. So always double check your answer if you have time. But that's it for A. Any question for A?
I just get confused when to use the stats button, the data button.
Okay, so let's kind of go back. All right, so I'm gonna show you an example of data and then stats. So when you want to use data, this is when you want to use data. Because if you look at it, they gave me the individual number for each one of these person. So they tell me like one person has 140 friends, another person has 105 friends, another person has 130 friends. So they gave us all of the data sets. So they gave me the 40 data set. But if I go back to this one over here, like for this one, they say they have 40 students. So do they tell me the age of each individual student in this? No, they don't tell me the individual age. They gave me X bar. They gave me sigma of X. Well, sigma, oh yeah, sigma. They gave me N, and they gave me the confidence level. So this is stats. So anytime they give you all of that information, that's the stats. But if they give you the raw data set, which is like the N, and just all the individuals that correspond to that N, then that's when you want to use data. So, does that make it a little bit clearer?
Yeah.
Okay. So let's do B. So if you look at B, all that's happening, instead of having a sample size of 40, is saying we increase the sample size to 100 students. So instead of having 40 students, what we're gonna do, we're gonna change it to 100 students. So let's go back to class calc, and we're actually gonna do this one in class calc. All right, so since all we wanna do, change it from 40 students to 100 students, we change 40 and we put it to 100. And that's our answer. So we'll say 22.65 all the way to 23.15. So if we switch it from 40 student all the way to 100 student, you get 22.65 all the way to 23.15. So let's go ahead back to the notes. And then what do you notice about these two confidence intervals? Which one became narrow, or which one became smaller? The first one or the second one?
The second one?
Yeah, the second one actually became smaller because if you look at it, it went from 22.56 to 22.65. And this one went from 23.29 to 23.15. So the confidence interval got smaller. So yeah, so you should kind of notice the confidence interval got smaller once we increased the sample size. That's it for that one. So let's do a new one. So anytime you're trying to do an interpretation about the confidence interval, because remember, for the confidence interval, we're not just doing one sample, you're doing many samples. So whenever you're doing interpretation, you want to do the interpretation like this right here. So if you look at the interpretation, it said if a large number of samples is collected and a confidence interval is created for each sample, approximately. So this is what's going to change. So depending on what your problem says, so if it says 95% or if it says like 99%, you change it to approximately that percentage. So say each sample, approximately 90% of the interval would contain mu. Because remember, what we're doing, we're just saying like, okay, if we constantly keep on repeating this, 90% of the confidence interval that we create, so if we create 100 confidence interval, 90% of them should capture the population mean. The other 10% shouldn't capture the population mean. So this is the incorrect way how to do the interpretation, because the incorrect way will say there is a 90% probability that the actual mean is in the interval of 22.3 to 23.5. Okay, if you kind of remember, like either the confidence interval will capture it or the confidence interval doesn't capture it. So it's either gonna be 100% or it's gonna be 0%. So that's why the first one is incorrect, because it's not talking about the process, it's talking about the probability of that individual confidence interval. All right. So what we're gonna go ahead and do now, we're gonna go ahead and do how to find how big of a sample size do we need depending on the confidence level and your margin of error. So let's get to the formula. Okay. There we go. So here is our formula that we're gonna be using for this part. So if I wanna figure out like how big of a sample size do we need, so all we have to do, we have to get Z multiplied by standard deviation divided by margin of error. And once you do that, you want to square it to the second power. So for this one is one thing that's very important. N should always be a whole number because N represents how big of a sample size you should have. So it doesn't really make sense for you to say that we have a sample size of 0.5 or 0.2 or 0.3. Your N should always be a whole number. So anytime we solve for this, we're always gonna round it up to the next whole number. But any question in regard to the formula before we go on? And this E right here is represent margin of error. All right, so no questions. So let's go ahead and do this problem. So for this one says Facebook, you want to estimate the mean number of friends for all users of the website. How many users must be included in the sample if we want a 95% confidence that the sample mean is within 7 friends of the population? Assume the population standard deviation is about 53. Okay, so they tell us we have 95% confidence level or confident. You tell us you want it to be within 7 friends. And lastly, we know standard deviation is 53. So for the 95% confident, we're going to use this to find Z star alpha divided by 2. So what I had to go ahead and do, I had to go back to that table and I had to look at 95%. So let's go back to this table. All right. So if you look at this table, we want to look at 95%. So 95% is here. So if you look at it, it's 1.96. So we're gonna use 1.96. So we get 1.96. Next thing, if you look at it, it says within 7 friends. So when they say within, the mathematical notation for within is plus or minus. So whenever you see within, you should kind of think about is plus or minus. So if you remember for the formula for confidence interval, what was the thing that we plus or minus? Well, we plus or minus the margin of error. So since they say within 7 friends, that means margin of error is equal to 7. And if you look at it, sigma is equal to 53. So now we have everything to substitute into this formula. So we're going to say n is equal to 1.96 multiplied by 53 divided by 7. And don't forget to square it. But any question, I got 1.96 times 53 divided by 7, all to the second power. All right, so I'm gonna go ahead and transfer over to ClassPass so that we can kind of see how I punch it in. So what you wanna do, you wanna do parentheses. So you do 1.96, and then you say multiply by 53, and then you divide it by 7. And then don't forget to square. That's where most of the students miss points because they forget to square. So if you square, we get 220.22. So you get 220.2256. Everybody good on the 220.2256?
Yeah.
All right, so let's go over and just switch over to my notes. All right, so if you look at it, I say 220.2256, but remember, you're always gonna round this up. So n is gonna equal to 220, and you're gonna round this up to 221. So for this one, we're not using the rule of thumb that says like if it's 5 or higher, you round it up. For this one, no matter what it is, just round it up to the next whole number. So for this one, since you have 220.2256, this 220.556, you treat it as a human being. So you upgrade it to a full human being, and that's why you get 221. And that's your n. And that's it. Any question in regard to the last prompt?
Do we always have to estimate it to a whole number, or just depending on how the problem's worded?
As long as you have a decimal, you always round it up to the next whole number. Like the only time you don't do it if n is exactly like 521 and there's no decimal. But pretty much you're always gonna round it up to the next whole number. So let's do some more of these and then that's it for today. I think this is the last one. So it says a researcher wanted to determine the mean number of hours per week, Sunday through Saturday, the typical person watched TV. Results from a survey indicate that the sample standard deviation is 7.5. So right here, we'll put sample standard deviation 7.5. So for this one, it says how many people are needed to estimate the number of hours people watch television per week within 2 hours. So if it says within 2 hours, that means that's the plus or minus 2 hours. So since that's the plus or minus 2 hours, what is that?
Margin of error.
Perfect. So you say E is 2 hours. All right, so that's a typo. It should say confidence, not condense. So if it says 95% confidence level, that means this is gonna help me get my Z star of alpha divided by 2, which should be 1.96. All right. So everybody got how we got margin of error of 2. Z alpha divided by 2 is equal to 1.96, and S is equal to 7.5.
Yes.
All right, so let's go ahead and do the formula. So the formula says you do 1.96 multiplied by standard deviation, 7.5. In this case scenario, it doesn't matter. It's a sample standard deviation. You could replace population standard deviation with the sample standard deviation. So in this case, it's okay to do that. And you divide this by your margin of error, which is 2. And don't forget to square that information. Any questions so far? I got 1.96 times 7.5 divided by 2, all to the second power.
No, it's good.
All right, so I'm gonna go ahead and transfer over to class count so that way I can punch it in and get my answer. All right, so in class count, we say 1.96, oops, 1.96. We multiply that by 7.5, then you divide that by 2. And then you close the parenthesis and you make sure you hit to the second power. And if you look at that, you get 54.0225. So 54.0225. So for this one, what should be my final answer?
55.
Yeah, 55, because we round it up and you get 55. All right, but that's it for that second part. Well, that first part of that problem. Any question for that first part? All right, so let's do the second part. So for part 2, it says how many people are needed to estimate the number of hours people watch television per week within 1 hour. So if you look at it, it's within 1 hour. So that's saying plus or minus 1 hour. And we still have a 95% confidence level. So that means Z star alpha divided by 2 is still 1.96. So if you look at it, the only thing that's changing is my margin of error. So when we do this, we're going to say N is equal to 1.96 times 7.5 divided by margin of error, which is 1, and you square. So if you look at the difference from number 1 to number 2, the only thing that's changing is my margin of error. All right, so let's go back to class count and let's punch it in. All right, so in class count, what I'm actually going to go ahead and do, I'm going to just edit it. So instead of putting 2, I'm going to switch it to 1. All right, so if you look at it, we get our answer to be 216.09. But for this one, what should be my final answer for this?
17.
Yeah, 217. And that's it for that final problem. Any question for that final problem?
No, sir.
All right. So if you look at both of these, if you look at number 1, if you look at number 2, which one is more accurate? So which one do they want more accuracy? Do they want more accuracy in number 1 or do they want more accuracy in number 2?
In number 2?
Yeah, so they want more accuracy in number 2. Because if you look at it, in number 2, they want a margin of error to be within 1 hour. If you look at the margin of error in number 1, they want it to be within 2 hours. So technically, they want a higher margin. Well, they want more accuracy in number 2 because we said the margin of error we want it to be smaller. So So the 7.5, it comes from over here. So so what happened if we made it more accurate? So if you look at it, if we want more accuracy, we need a bigger sample size. Because if you look at part 1, it said we only need a sample size of 55 if we wanted it to be within 2 hours. But if I wanted it to be within 1 hour, now we need 217 as a sample size. So for part 3, it says, what effect does doubling the required accuracy have on the sample size? Well, it made the sample size bigger. So that's the effect that doubling the required accuracy have on the sample size. It made the sample size bigger. So if you want more accuracy, which means you want a smaller margin of error, you're gonna require a bigger sample size. All right, so that's it for that. Cool. All right, and then the next part, that's gonna be for tomorrow lecture. So we're all done for today's lecture. Any question in regard to today's lecture?
No.
All right, cool. So what I'm gonna do today, I'm actually gonna cut the class off right now then. And what I'm gonna do, I'm gonna have office hours from now all the way to 12 p.m. So if you have any question about what we went over today or what we're gonna go over tomorrow, well, not tomorrow, or if you have any question about like what's gonna be on the test or what type of question is gonna be on the test, well, not the test, on the quiz today, you could just jump onto my office hour and that way I can help you out with that. But pretty much right now, we have cut off the class and we're gonna do office hour right now. Any question in regards to that?
For the homework, do we start doing it or do we wait till tomorrow's lesson's over?
Yeah, you do start doing the homework because you could do part of the homework and I'll show you which part you should be able to do. Let me get that. Cool. And yeah, you should do activity number 18. Because the thing is, like, if I put you in group and stuff like that, you might not have enough time. So I'll probably just do office hour and hope that's better. So let me see. All right, so for the homework, what you want to go ahead and do, this should be for this confidence interval. So chapter number 8. Go over here. So if you look right now, it says confidence interval sigma known. So that's what we did today. Confidence interval sigma unknown, that's what we're going to do tomorrow. So you should be able to start doing this homework right now. So that's the homework you want to be working on. And for the activity that you want to be working on is activity number 18. So you could start doing activity number 18. And then for today's quiz should be quiz number, pretty sure should be 16. Cool. Yeah, so quiz number 16. So remember, this is gonna open up at 12 p.m. and it's gonna close at 11:59 p.m. And for this one, you're gonna have same thing. You're gonna have 40 minutes to be able to do this quiz. So shouldn't hopefully take you that long, but if it does, it does. All right. Any other questions? Cool. All right, guys. So remember, I'm going to cut off right now and I'm going to go to my office hour. So if you do have any questions, just drop by on my office hour. And also, Erica, if you could just drop by for our meeting today, just go to, do you have access to the Blackboard where it has office hours?
Yeah, I can see the link, but anytime I've ever pressed it, it doesn't let me actually join the office hours meeting that you have.
Okay, so I'll send you the link for today's meeting.
Okay, thank you.
Yeah, thanks, Erica. All right, guys, so that's it for today. So remember, we're almost close to finishing off the semester. So this is a time where you kind of want to finish off strong. So that way, like if you haven't been doing good on the last quizzes, these are the quizzes you kind of want to do good at, because like for this one, like the material is significantly harder. So if I do see that you're doing way better on these material versus earlier, like it will boost up your grade. So just do your best for these following weeks. For that way you can pass the class. So just keep on working, keep on doing and doing what you're doing. And if you need help, just email me or just email me and just go to office hour. Also remember today you're gonna have a workshop. So do go to today's workshop because that will only help you, is not gonna hurt you. So do attend workshop. They're there to help you. And remember they're part of your grade. So pretty much that as long as you attend workshop, you get those points. So those are easy points for you. All right, so I'm gonna stop the meeting and I'll see anybody in my office hours.